Okay, so I think the first question, the earliest one on that was asked about was 13. So this one, it says find solutions to the equation, and then it gives the solutions almost in, it gives them an exact form, which is like you had done the quadratic formula to solve them, basically. So what I would do is I would graph this in Desmos, x squared minus 3x plus 5, 2x plus 10, and I would see what the decimal answers are. So let's go ahead and look over at Desmos. So x squared minus 3x plus 5, 2x plus 10. So we'll get the decimal answers from here. And then I'm going to write those down. So I've got negative 0.854 and 5.854. And then from there it says, okay, but the answers are given to you in exact form. And so it's kind of like you've done the quadratic formula to solve the problem. So you can type this part in Desmos, or you could type this part in your graphing calculator. It doesn't matter. So now I'm going to check which of these exact form answers matches those decimals. So 5 plus 3 square root 5 over 2. Oh, it looks like it's the first one. Yep, looks like it's the first one. Yep. Does that make sense? Okay. All right, the next one I had a request on was number 20, which has that function notation. It says f plus g of x plus 3. So it's telling you what to plug in for x. So this notation really means f of x plus 3 plus g of x plus 3. That's what that notation actually means. So I'll go ahead and write down what f of x is. It's 3x squared, and then g of x is 2x minus 5. And then what they're asking us to do is to take the x out and to put x plus 3 in its place. So take the x out and plug in x plus 3. Take the x out and plug in x plus 3. So you're going to end up with 3x plus 3 squared, 2x plus 3 minus 5. And then from there, just like the other ones, you're finding an equivalent expression, and so you can just graph and see which one would be the same. Mm-hmm. I didn't do the answer, I just helped you set it up. Yeah. Did you get this part? You guys can do it from here. So at this point, all you'd have to do is graph this, and then graph these, and then see which one's the same. Yeah. Yeah, then you'll be good. Okay. For 21, they give you f of x and they give you h of x. And then down here, they're telling you to take the f of x and to evaluate it at negative 2x, and they're telling you to take the h of x and evaluate it at 1/2 x. So I'm going to start just by plugging in the f of x and the h of x. So f of x is x squared, h of x is 4x. And then you have the x in the problem. And so for this x right here, they want you to plug in negative 2x. And for this x right here, they want you to plug in 1/2 x. So we're going to take the first one and we're going to plug in negative 2x. And we're going to take the second one and we're going to plug in 1/2 x. And then from there, all you have to do is just graph it with your answer choices and see which one matches. Okay, 25. So you just have to put a check in whichever column has this transformation. So we're going to do first, second, or third column. Which one has a reflection over the x-axis? First, second, or third column? First, because it has a negative in the front. Okay. Which one translates h units to the left? First, second, or third column? Third goes to the left because it says plus h. That goes to the left. Okay. Which one translates k units up? The second column. Okay. And then which one has a vertical dilation? Vertical stretch or compression would be the second column. Okay. Looks like the next one we have a question on is 49. Did everyone get 41? Okay, I had a lot of people ask on 41. Yeah, 41. Okay. So with this one, you can graph the question and you can graph the answer choices, but the answer choices are not ready to graph the way that they look right now. You have to write them out. So it says quotient and it says remainder. So answer choice A is x to the third minus 3x squared plus 6, and it has a remainder of 1, so you're going to write plus 1, and the 1 is still being divided by x squared plus 1. So that's answer choice 1, or answer choice A. Answer choice B is x to the third minus 3x squared plus 7 over x squared plus 1. Answer choice C is 4x plus 5 plus the remainder is x to the third minus 2x squared minus x plus 2 over x squared plus 1. And then answer choice D is x to the third minus 2x squared minus x plus 2 plus 4x plus 5 over x squared plus 1. So you can still graph the original problem and the answer choices to see which one is correct. You just had to write the answer choices out before you did it. Okay, 49 says how many non-real roots does the polynomial function have? So this one you can't do as easily in Desmos. I'll kind of explain a way you could do it in Desmos, but this one you kind of have to know how the problem works. So if you think about problems that are in the factored form, how do we find the roots or the x-intercepts? Remember, root is a synonym for x-intercept. So how do we figure out from the factored form what the x-intercepts are? Kind of. Like maybe from this one, if you look at this one, what would you say the x-intercept was? You'd say it's -5/3. So back in the day when we first found it, when we were first solving from the factored form and we were first finding x-intercepts, do you remember how you learned how to do it? You would take the factor and what would you do with it? You'd set it equal to 0. So if you had a factor, and let's say the factor was x plus 5, then to solve it, you would say x plus 5 equals 0. You would minus the 5 over, and then x would equal -5. Or if you had the factor x plus 1, you'd subtract the 1 over x equals -1. Or if you had x minus 7, you'd add the 7 over x equals 7. That's how you would solve your factors. This is actually the same way that you can find non-real roots in a situation like this. So you can take each of your factors and you can find the one where if you try to solve it, it solves to give you an I. It solves to give you something that's not real. So if we look at this one, we have 3x plus 5 equals 0. And if we were to solve it, we would subtract the 5 over, and then we would divide by 3, and we would get x equals -5/3. That's not a problem. That's a good answer. If we get x squared minus 4 equals 0, I can add the 4 over, I can square root 4, that's not a problem. How many answers do I get when I square root 4? I get 2 answers, plus or minus 2. That's a good answer. If I do x squared plus 16 equals 0, what happens? I subtract the 16 over, and then what do I end up square rooting? A negative. What happens when I square root a negative? You get an I. Yeah, you get unreal answers, right? You're going to square root a negative number. You can mathematically keep going, but it's not a real answer. It's an imaginary answer because you square rooted a negative. So these right here are going to be negative answer or imaginary answers. And how many of them are we going to have? 2. One for the positive, one for the negative. Over here, we have x squared minus 7 equals 0. I add 7 to the other side, I square root it. It's not a nice answer, it's a decimal, but it's still real. So 2 non-real roots is what I have. And it's because of the x squared plus 16. Does that make sense? All right. Would one of you guys mind closing the door for me? Thank you so much. Okay. 54, you should be able to plug straight into Desmos. It just says this is divided by that. So you'd have 3x to the 5th minus 15x to the 4th plus 4x to the 3rd plus 11x squared minus 9x plus 2 being divided by x squared minus 5x plus 2. and then it should equal one of those. So it should be the same. The picture should be the same. Sophie, you got it?
Yeah.
Okay. Mm-hmm. Yeah, you would just graph this and then graph all of these and see which one is the same. Mm-hmm. Okay. For 55, it says, suppose this is what you have. The remainder of the division of P of X by X plus 1 is -8. So if we do X plus 1 being divided into this, X to the third minus 2X squared plus 13X plus K. If we do this long division problem, we're going to get down here, we're going to get a remainder of -8. We did that long division problem. How could we use the remainder theorem to help us do this problem to make our lives easier? Anyone have any ideas? How could we use the remainder theorem? Yeah, Sean. Okay, X plus 1 equals 0, so X equals -1. Okay, and then what do we plug into the X's? Wait, not the remainder, you plug in the -1. And then when you plug in the -1, it's going to spit out -8. It's going to give you the answer -8. So we're going to plug in, we're going to do -1 to the third minus 2 times -1 squared plus 13 times -1 plus K. And when we plug in all those -1s, it's going to give us -8 because it always gives you the remainder. So when you take this, the opposite of this factor, and you set it equal to 0 and you solve it and you get -1, when you plug that into the function that you're dividing, you get the remainder as an answer. So I'm just going to do that and see what I get real quick. You could do this on Desmos, you can do this on your graphing calculator. So I've got -1 to the third minus 2 times -1 squared plus 13 times -1. So I've got -16 plus K equals -8. So what does K equal? Yeah, K equals 8. Okay, so I solved that. Is that what the problem wanted me to find? No. What do they want us to do now? Okay, so now we know what P of X actually is, though. Now we know that it's not just plus a K on the end, it's actually plus an 8 on the end. So we know that this number here on the end is actually an 8. Now we can do the problem again, but this time we're dividing by X minus 1. And they want us to tell them what the remainder is if we do X minus 1. So now we're going to say, okay, X minus 1. And we're dividing X to the third minus 2X squared plus 13X plus 8. And we're going to do the whole division problem, and we're going to get a remainder, and that remainder is the answer. That's what they want us to tell them. Do we have to do the whole long division problem and get the remainder, or could we do a shortcut? We could do synthetic division. Do we have to do synthetic division, or could we even shortcut that? Could we do the remainder theorem? Could we do this thing again? Just with this instead? Yeah. So what should I be doing? Okay, so I'm going to say x minus 1 equals 0. So x equals positive 1. I'm going to use a positive 1 this time. And I'm going to plug a positive 1 into the function. So I'm going to do positive 1 to the third minus 2 times positive 1 squared plus 13 times positive 1 plus 8. I'm going to see what it evaluates to be, and whatever that is, that's the remainder. Does that make sense? So that means we didn't have to do any division for this problem because we used the remainder theorem for the whole thing. That's what got us out of doing division, the remainder theorem. Okay, so the answer is 20. So that means that if we had done the division, we would have gotten 20 as the remainder for the division. How do your guys' brains feel? Are we okay with that one? Okay. All right, 56 was another one of the requested problems. It has, this is kind of what I was referring to with 38 when I said if they ask you to find all real and complex roots, or if they ask you to find the complex roots, that 38 was a really nice problem because the real roots were different. So with 38, all we had to do was graph it. We could see what the roots were, and then we were done. But if the real x-intercepts were all the same, then we would have to actually do the process. So remember, the process is find the x-intercepts, do synthetic division with them. From the synthetic division, you will get a quadratic, and then you'll do the quadratic formula on that quadratic. The problem that you have to do this work on is number 56. So if you look at number 56, they say find all real and complex roots, and then the real root that they give you and all 4 of the answer choices is -1. They give you -1 for all of them, which means that this is the one where we have to do that 3-step process on it. So let's go ahead and graph x to the third plus 1, because we want to see if it's -1 with a multiplicity of 3, or if it just goes straight through -1 and we do have complex roots there. So I'm going to look at Desmos and see what x to the third plus 1 looks like. So x to the third plus 1, it does have an x-intercept of 1, but it of -1, but it is not a multiplicity of 3. It just goes straight through, which means it has 1 x-intercept right there. So our answer choice is not A, it could be B, C, or D. We're just not sure which one it is. So we do have to go through the rest of the process to see. So we got rid of A, that was not a multiplicity of 3, it went straight through. So now we have to do synthetic division. And then once we are done with synthetic division, we have to do the quadratic formula. So this problem, we can't really cheat the system. We basically have to do the problem the way it's meant to be done. So I start by saying x equals -1. I remember that when I do synthetic division, I have to have all of my exponents. So I have x to the third plus 0x squared plus 0x plus 1. So I have to have all of my exponents represented. So -1 goes in the box. And then what should I be writing here? Anyone remember? Yeah, 1, 0, 0, 1. And then does anyone remember what the remainder would be? It would be 0 because this is an x-intercept, which means that as a factor, it would divide evenly. Okay, so I drop the 1 down. 1 times -1 is -1. 0 plus -1 is -1. -1 times -1. 0 plus 1. 1 times -1. And then 1 plus -1 is 0. Now, since this had an x to the third, that means that this is an x squared, this is an x, and then that one doesn't have one. So we have x squared minus x plus 1. And then this is what we're doing the quadratic formula on. And when we do the quadratic formula, we're going to get either answer choice B, C, or D. So the quadratic formula is b squared minus, sorry, plus minus. Goodness gracious, I totally forgot the quadratic formula. -b plus minus square root b squared minus 4ac all over 2a. I'm sorry, I was leading you guys astray. Okay, so if this is the quadratic formula, and this is the quadratic that we're working with, what should I be writing first? You're close. +1. So we have a negative in front, so we should have negative of -1. So negative of -1, which makes a +1. All right, and then what should we have? -1 squared minus 4 times 1 times 1, all divided by 2 times 1. Okay, so that's +1 plus or minus, it's over 2. That's a 1 minus a 4. What's 1 minus 4? -3. Can you guys tell which answer choice it is? Answer choice B. Okay. All right. Yeah. Mm-hmm. All right, the next one is number 60. Number 60 is kind of a vocabulary question almost. It says, which function has a minimum value less than the minimum value of g of x? So this is g of x. When it says minimum value, the way that it says it, is it talking about the x coordinate or is it talking about the y coordinate? It's talking about the y coordinate. So what is the minimum value? So if it said, where is the minimum value, it'd be talking about the x coordinate. But if it says what the minimum value is, it's talking about the y coordinate. So we talked about this in our notes when we initially took them. It's a very subtle difference. If it says where, it means the x value. If it's talking about the what, it means the y value. So since they're talking about what the minimum value is, that's why you know that it's referring to the y value. So which function has a minimum value that's less than g of x? Well, g of x's minimum value is what? -3. So we are looking for, between A, B, C, and D, we are looking for whichever one has a minimum that is less than -3. So this is definitely a Desmos question. We just have to graph and see which one is lower than that. So let's see, x to the 4th plus x to the 3rd minus 3x squared plus 2 -3.248. I mean, that's definitely lower. Is it A? Did anyone get a lower one than that? Okay. And that's convenient whenever it's the first one. Yeah, it's not B. B is higher. C, 2x to the 4th minus x to the 3rd plus 2x minus 2. Yeah, it doesn't look like it's this one. -2. Nope. Yeah, I think A is probably it. 2x to the 4th. Yeah, looks like it's definitely A. A is the lowest. Okay. All right. 69. What was confusing about 69? Just graph it. You can just graph, it's just solving an equation. So graph this, graph that, and see where they cross. Yeah, you're good. Okay, 72. What's the confusion on 72? Typing it in? So this, we're just graphing the problem, graphing the answers, and see which one looks where they should graph identically. You can hit a times in between them. So graph one fraction, graph the other. So I would type it just the way it looks. So this one times like this. So x squared minus 11x plus 28. So there's the original problem, and then just type in your answer choices, but that's how I would type it for 72. Okay. 74 says to find the positive root. Okay, find the positive root of 1 over x minus 1 Okay, so if you solve that problem, the positive answer that you get is 2. I don't, yeah. I'm thinking maybe they're talking, well, let's try it this way. If you were to subtract this one over, it might look more like a root. That's why they called it a root. Because if you solve it that way, if you were to do the problem by hand, that's how you would solve it, is you would subtract it over, you would set it equal to 0, you'd get a common denominator. So if you were to solve the problem by hand, it would be a root. Yeah, good question. Okay. Any other questions? Yeah. Yeah, because 11 and 9 are the same. And so that's why I skipped 11. Yeah. Any other questions? Okay, so at this point, we are just work time to get your answers plugged in. If you run into any issues, feel free to ask. If you need me to clarify anything, other than that, you guys are set. Yes. As soon as you turn them in? Yeah. So, oh, and then the other thing I'm planning on doing, you guys, is after midnight tonight, I'm gonna post the answer keys that have, I'm pretty sure, hold on, I can clarify this in just a second. Yes. I have the answer keys that have all the work the way it is intended to be done. And I will post the work the way that the problem was intended to be done once they are turned in after midnight. So tomorrow morning sometime is when I will post the answer keys. And then for any question that you are interested in, like seeing like, oh, how is that supposed to be done? Or you want to know what the right answer was or whatever, you can check your answers and stuff like that on the answer keys as soon as they're actually due. All right, perfect.